Bright Duty. Every student matters.
Hello students, now let's solve questions so that we can have a better understanding of what we have learned so far. So for the first portion, we'll be targeting certain easy questions from in-text as well as exercise. Why should curd and sour substances not be kept in brass or copper vessels? Now you know that metal reacts with acid and forms a salt plus hydrogen gas. Now that you know of this reaction, you also know that there are acids present in sour substances and there is lactic acid present in curd particularly. So when you put these acid in contact with metals by keeping them in brass or copper vessels, then they react with one another and the food reacts and the food goes bad, so it is not consumable anymore. And that is why it is not advisable to keep any sour substance inside of a copper or a brass vessel. Which gas is usually liberated when acid reacts with metal? Illustrate with example, and how will you test for this presence? Now, as explained in the previous question already, that the hydrogen gets removed from acid and metals takes its place. That is how this reaction occurs. That is why hydrogen gas is liberated. It is liberated when metal replaces hydrogen ion from the salt, like shown here. So here's the example that Na plus HCl. So H gets removed and Na takes its place, so it becomes NaCl and H2 gas. Gas gets released. So to the test for the presence of hydrogen gas, you bring a burning matchstick near the end of the test tube where you've taken the reaction place, or you can also have a setup where the test tube has a connecting wire going inside a water bath, which will be soapy in nature. So because of the soapy nature, it will form bubbles, and you bring a burning matchstick near the bubbles. What happens in either of the situations is that hydrogen gas, when brought close to a burning matchstick, burns with a popping sound. So whenever you hear this popping sound, you can be certain that hydrogen gas is being released. You can either perform this by forming soap bubbles, which is a more distinct method, but you can also bring a burning matchstick at the face of the test tube. Metal compound A reacts with dilute hydrochloric acid to produce effervescence. The gas evolved extinguishes a burning candle. Now we know this from all the fire extinguishers that we usually have at our homes, that extinguishing property in a gas is only in carbon dioxide. So we know that this gas which is being produced is carbon dioxide. Write a balanced chemical equation for the reaction if one of the compounds formed is CaCl2. So we know that calcium chloride is being formed and CO2 is being formed. The moment I see these two things, I understand that the compound has calcium and has carbon in it, which means it is calcium carbonate. Marble or even chalk has calcium carbonate in it. So calcium carbonate is reacting with dilute hydrochloric acid to form CaCl2 plus CO2, and H2 would also be released because we need to remove this hydrogen. The hydrogen needs to be balanced. So that is how you can remember this reaction, that because of the presence of carbon dioxide, you know it's a carbonate. Because of the presence of CaCl2, we know it's calcium carbonate, and so we are able to decode this equation. A solution turns red litmus blue, its pH is likely to be. So we know for the pH scale, it starts from 0 and ends at 14, where 7 is neutral, and this area is acidic in nature, and this area is basic in nature. So we know if they are saying that it turns red litmus blue, blue means it is already basic in nature. So we want something between 7 to 14 because basic things will have a pH in that range. Now 1, 4 and 5 are not options because they are less than 7. So the answer remains 10. anything that is above 7 would be basic in nature. The more the number, the higher would be its basicity, and likewise anything less than 7, closer to 0, would be acidic. A solution reacts with crushed eggshells to give a gas that turns lime water milky. Now this is our cue. We will find out the gas based on this. The solution contains which of the following options? Now crushed eggshells, you know that eggshells have CaCO3 in them. They are made of calcium carbonate. We know that the gas that turns lime water milky is always CO2. How do we know this? Because we have done a test for identification of CO2, which is that it turns lime water, slake lime, milky. So we know one of our initial reactants, and we know one of our products. Now it is being reacted with something. If we react CaCO3 with NaCl, then this reaction would not occur because NaCl is a salt. We need something which is acidic in nature for this reaction to occur in this process. That is why the answer would be HCl. CaCO3 plus HCl forms CaCl2 plus H2O plus CO2. You have studied this equation in your reactions that acids show, and you will be able to understand this now. We've also done this in a previous question, the same equation in a different format. The whole idea here is that you identify the substances based on their properties, like based on the fact that it turns lime water milky or that it extinguishes fire. We know that it is CO2 that we have been talking about. Okay, so let's move on to the next question. 10 ml of NaOH is found to be completely neutralized by 8 ml of given solution of HCl. This is a question of simple arithmetic nature, that 10 ml of NaOH will form a neutralization reaction with 8 ml of HCl. Now if we take 20 ml of NaOH, that is we double the NaOH, then how much HCl would be required? Now because this equation goes like this, you see there is no 2 here or here. It is a simple equation where one of each molecules is reacting to form one of each products. So if this becomes double, then this will also have to become double for this reaction to occur. This is not the way to balance the equation. I'm simply trying to explain you that for one quantity of NaOH, we need one quantity of HCl. So if this gets multiplied by 2, this would also get multiplied by 2. So if 10 ml was doing this reaction, then and 8 ml was doing this, then it means 8 into 2, 16 ml would be appropriate for this reaction to completely neutralize each other. Okay, so this is very simple, basic question. Don't get carried away by the thought that you've not done something like this. It's just that the equation is balanced, and that is why the same units would be required next time, so the double amount. Write the word equations and then balance the equations for reaction taking place when. Let's do it part by part. The first says dilute sulfuric acid reacts with zinc granules. So we know sulfuric acid is H2SO4. When it reacts with the metal, we've already established it forms a salt and hydrogen gas is released. So the H gets removed from this and zinc takes its place. This equation is of a reaction of acid and a metal. Very simple part. Let's move on to the next part. Hydrochloric acid reacts with a magnesium ribbon. Again, similar reaction. You take HCl, you add magnesium to it, H would get removed. It will form MgCl2 and H2. Now this equation was not balanced because hydrogen was double here and chlorine was also double here. So we put a 2 here and the equation is now completely balanced. Moving on to the third part, dilute sulfuric acid reacts with aluminium powder. Now don't get confused by the fact that they are calling it a ribbon or granules or powder. In either of the situations, the reaction would occur with the same format. It's a metal reacting with an acid. So the metal reacts with acid, hydrogen gets removed, it takes its place. So it's aluminium sulfate and hydrogen gas. To balance out, because of the 3 here, we have to put a 3 here. And because of this 3, we have to put a 3 here. And that is how this equation also can be easily balanced out. And the last one is dilute hydrochloric acid reacts with iron filings. Again, don't get confused by the format of the metal. So let's move on simply. We have iron, we have HCl, we react them, and we know that iron and chloride would react to form iron chloride, and hydrogen would be separated out. So you have to realize that iron chloride is FeCl3 and not FeCl2. Iron has this property, so because of which I would request you to pay special attention here that it's FeCl3. Now we have to balance it. So because we will start balancing with chlorine. So because of 3 we have to put a 2 here. Because of this 2 we have to put a 2 here. And to balance out the hydrogen we put a 3 here and a 6 here. And the equation is completely balanced out. You have been provided with 3 test tubes. One of them contains water, distilled water. Other 2 contain acidic solution and a basic solution respectively. If you are to be given only red litmus paper, how will you identify each? Now it may seem like it's a difficult question, but it's really simple. What you have to do first is that you take a the red litmus solution and you put it in all 3. Put a little bit of take a little bit of red litmus solution and make it react with all the 3 different solutions that we have. One of them, which is acidic, which is basic, would turn red litmus blue. So we will have identified our basic solution. When we put red litmus on it, it will turn blue. Now we have 2 solutions remaining. But when you put red litmus solution on a base, it converts it into a blue litmus. Now you can use this newly formed blue litmus and again use it on the remaining 2 solutions. So for instance, here we have solution A, solution B, solution C. I already know that this is a base because it turned my red litmus into blue. Now from this reaction I was able to form blue litmus, which I in turn use in both these. One of them would turn blue litmus red. That would be my acid, because acids turn blue litmus red. So acid would turn blue litmus to red. And the one which would not react to either of the solutions would be distilled water, because distilled water is neutral. It shows neither acidic properties nor basic properties. So now that you've understood, let's move on to the next question.